Hi everyone, I'm Anqi from Zhejiang University. Today I will introduce our paper, Action-Evaluator, a visualization approach for player action evaluation in soccer. In soccer, action evaluation means evaluating players' indirect contributions to the team through their fine-grained actions. For instance, in such a match situation, the player could make several action choices, such as passing to teammates or taking the ball to midway. The player should choose the best action that could contribute most to winning the match. In the match, the player chose passing to the teammate who was near to the goal. It is a successful action choice because it significantly increased the chance of winning a goal. To help players make the best choice in matches, a series of data-driven models have been developed to evaluate players by statistical indicators or fine-grained action scores. However, analysts often encounter difficulties in investigating action scores by complex spatial-temporal match situations to summarize the player's strengths and weaknesses. Several interactive visualization tools have been proposed for in-depth soccer data analysis on ranking table, tactic discovery, and player evaluation. However, the investigation of fine-grained player action scores is still hardly supported. In this work, we develop Action-Evaluator for flexible exploration, comparison, and explanation of player actions and these scores. In the player view, users can navigate players by their importance and the similarity. In the action view, users can investigate action scores of a certain player by match situations and different action choices. In the explanation view, users can compare the action choices from different players and explain the scores of individual actions. We faced two major challenges during the system development. The first challenge is to integrate essential match situations into the visualization of actions and their scores, including team tactics and player locations, to understand the tactical intentions of the action choices. The second challenge is to design visualization tools for effective action score comparison and explanation, which helps figure out how to improve player performance through action choices. To address the first challenge, we designed a pitch-based visualization for soccer actions that places the action choices with the match situations in the same view. It includes a match situation diagram and an action choice diagram to present match situations and action choices in soccer matches. In the diagrams, the tactic is represented as a sequence of pitch regions and encoded by links between the regions. The pitch is divided into 9 spatial regions, including the defensive third, the middle third, and the attacking third, based on the common pitch division method. To identify the tactic, we find the possessions that the actions belong to and cluster the possessions into groups. Then we discretize the actions of each possession in the cluster and obtain the representative sequential pattern as the tactic by the pattern mining algorithm. As for the player location, we abstract it as defensive pressure value and encode it by a gray bar chart placed along the pitch. The defensive pressure value is calculated based on the average distance between the ball controller and the opponent players. To address the second challenge, we collaborated with 3 soccer experts and developed design requirements in 3 aspects, including player navigation, action investigation, and action explanation. We first introduced the calculation of action score. We used the expected possession value framework, which focuses on player actions in a possession. A match state is a subsequence of the possession. Then the expected possession result can be predicted by a classification model given the match state. The action score is calculated by the change of the expected possession result. The classification model contains a player embedding component and a sequence prediction component. With the player embedding component, players who contribute similarly through their actions would have similar embedding vectors learned by the model. The sequence prediction component predicts the expected possession result on both risk and reward. The risk score indicates the chance of the possession still maintained after the action, and the reward score means the chance increment of winning a shot or goal caused by the action. As for player navigation, we design a player view, including a player ranking list and a player projection component to present the similarity among the players. The player ranking list presents players in a sortable list to assist the navigation of the target player. Each row of the list indicates a player, which consists of the indicators to represent the player's importance, including the total action number and the succeeded action number for each action type. Analysts can filter the players according to their teams and roles, filter out the top N players, and sort players by the indicators. The player projection component is a scatter plot presenting similarities among the players. Each player in the scatter plot is represented by a glyph, and the player similarity is encoded by the distance between glyphs. The glyph contains three metrics to indicate the overall performance of the player, including the total action number, the overall risk score, and the overall reward score. As for action investigation, we design an action view, including a match situation list to specify the match situation of interest, and an action score list to present the scores of different action choices. The match situation list presents the action scores in multiple match situations with a sortable list. We provide a player action heat map for selecting actions by start region for further analysis. Each row of the list indicates the actions conducted in the same match situation, containing the match situation diagram, the average reward and risk scores, and the frequency of the actions. The action score list is a sortable list of all action choices conducted under the selected match situation. Each row of the sortable list represents an action choice, including the action choice diagram, the average reward and risk scores, and the frequency. Analysts can filter and sort the action choices by the action scores and the frequency. Each row can also be unfolded to a sublist to show the scores and frequency of the action choice by matches. As for action explanation, we design an explanation view, including a record list to compare actions from different players, and a goal speech to display individual actions and the results of alternative actions. The record list records the selected actions to compare action choices from different players. Each row in the list consists of the action choice diagram, the average reward and risk scores, and the frequency of the actions. A certain row can be unfolded to a sublist to represent individual action contained in this row. The goal speech displays detailed information about individual actions and illustrates the results of alternative actions by heat map. Analysts can also switch the heat map between the reward and risk scores or among the alternative action type. We evaluate the system usability with two case studies conducted by two experts respectively, including the analysis of two different players. After the case studies, we interviewed the experts to collect their feedback. Both experts appreciated our system and proposed several suggestions to improve the system. In conclusion, we characterized the domain problems of soccer player action evaluation, propose a tailored visualization for soccer player action, and develop a visual analytics system for soccer player action evaluation. In the future, we will integrate fine-grained soccer match data into the action score estimation and extend our system to other team sports like basketball and ice hockey. That concludes my presentation. Thank you.